Okay, this will address one of the homework problems from the online assignment C. And what we're really doing here is thinking about how to compute the average of a bunch of numbers, but when the description of the numbers is sort of squished into table form, it'll feel a little bit different. Before I deal with the question that's here, because it addresses trying the average of 4,404 subjects, let me just do a simpler example first. There. So if I were really computing the mean, I would have 0 plus 0 plus 0 plus 0 a whole bunch of times. In fact, exactly 3,950 times. Then I would have, after I have a whole bunch of those, I would have plus 1 plus 1 plus 1 a whole bunch of times. Right, and exactly 289 times. And then I would have 2 plus 2 plus 2 a whole bunch of times, exactly 91 times, and so on. And so then I'd have some threes, and then the category they're trying to get at here is this 4 or more, which is kind of what people do if they don't want to have to list all the possibilities, but they just take all the numbers that were big and lump them together. The problem is 4 or more is not a number, so I can't add that into this sum, and that's what this question is about. It's giving you one way to interpret finding a mean in that case. What you normally do is you just pick something there because it can't possibly matter that much. If there's only 30 of them, it's not going to have a huge effect compared to the other 4,000 numbers. But if you don't pick something for those, then you can't do the average at all. All right, so here's how the multiplication idea would help. This we don't really need help with, it's just 0, but technically that's 0 times 3,950. Technically, this is, we don't need a ton of help with this one either, but it's 289 times. This would be the number 2, 91 times. And those numbers, the number of times those occur, I'm getting out of my table. The table says that we're going to have the number 3, 44 times. That's what this row says. And then they tell us for 4 or more, we're just going to use, as our number for our average, we're just going to use 4.5 there. And there's no wrong thing to use. I probably wouldn't use a fraction number just because a half is not a possible answer to this question. I'd probably use 5 or 6 as my answer, but it won't have much difference in the final answer because so many of the numbers are already accounted for. So if we use 4.5 as they suggest, that means I would be adding 4.5 for each of those 30 things. So this altogether would be the sum of all of the different answers that anybody gave. If I had written them out the way I was writing it up here, I would have had to write out 4,404 numbers. If I write it this way, where I use multiplication to capture the fact that when I add the number to itself, that's what's happening, it's a much easier thing to calculate. And then, so that would be the numerator of my expression where I'm trying to find the average. I would take that answer to what's in the blue box and divide by 4,404. So that's how I would get the sum of all of the possible answers. I get the sum of all 4,404 answers divided by 4,404. And I believe, if you want to check it for this one, I think it's telling me that the answer is about 0.17, which makes sense. It should be close to 0 because the vast majority of answers are 0. Notice that the median, part B is going to ask about the median. The median will be the middle number in this long stretch, this 4,404 numbers that you wrote up here. The median is going to be the middle value of that. Because there are 4,404 numbers, the first, half of that would be 2,202. The number that comes after 2,202 is somewhere in here. Right, this is 3,950 zeros. So the first 2,202 of these numbers are 0. the next number is 0, the next number is 0. So the median is actually happening somewhere in the middle of all of this stuff is where you're going to get the median. So the median value, that'll be the B part, the median value is 0 because from that original list I can picture what the 2,202 or 2,202nd value is going to be in the list. So I have to use my imagination a little bit. I would advise writing out the numbers with a lot of dots to get a sense of what the data looks like. It's so many numbers that it's going to feel different than the ones we did in class where we only had 50 numbers. But ultimately, what you're doing is you're saying my data in order is just a whole shitload of zeros first, then a whole bunch of ones, and then a whole bunch of twos, a few threes, and then some bigger numbers. But there's only a few bigger numbers, and we know exactly how many numbers there are in each of those categories. So not only can we add them up fairly quickly using multiplication, we can also see where the center is, where the middle value is, somewhere in the middle of that list. Okay, let's suppose that I grabbed a group of 5 of you and asked about your ages, and let's just assume that that one of you had, in the group of 5 I picked, one of you was 19, 3 of you were 20, and 1 of you was 23. Then if I were taking the average, or the mean, of these numbers, we know that we would just take the sum and divide by the number. Right, so that's our idea of average. Notice that adding 20 to itself 3 times is not a big deal here because there's only 3 of them, but that's exactly the same thing that if I were to take that 20 plus 20 plus 20 I did in the middle, that's the same thing as just saying 3 times 20. So even though in this case it doesn't really speed things up very much, I could have done 19 plus 3 times 20 plus 23 and then divided that by 5. So that idea that when you add the same number over and over again, it's the same as multiplication, it doesn't have a lot of payoff when there's only 3 of those numbers, but when you have a lot of them, thinking of it that way can actually speed things up quite a bit. The B part, that's where we are in this problem. Notice that we're told the answer to this question within the past month, how many people have you known personally who were victims of a homicide? It's a horrible question. But there were 4,404 subjects who answered. 3,950 of them said 0. So when I'm computing the average, I didn't mean to go to this slide. Sorry, I got one step ahead of myself. This then really asks you to hold things in your head. It says, what if I were to move 1,650 of these people? What if suddenly 1,650 people, instead of knowing 0 victims of homicide, suddenly knew 4 or more? So suppose that many people, 1,650 people, moved out of that category and moved into this category. Right, did that. So all that's going to do is give us a slightly different table. So our table now, in the first row, instead of 3,950, it's going to say 2,300. Because I just reduced 3,950 by 1,650. I just subtracted. The number in this category, ones, is 289. That's the same. The number of people who said 2 is still 91. The number of people who said 3 is still 44. But now, in this hypothetical situation, the number that say 4 or more, 4 plus, is not 30, but 1,680. So I added the 1,650 people to that last category. So this is the new table they're asking us to consider for part C. And what they're asking is, what changes when you do that? Well, if you can't quite tell, just do the calculations again. What you're going to see is that the mean is going to go way up. The average goes way up because every number you were adding as a 0, you're now adding a 4.5. So the mean increases, and it increases quite a lot above the 0.17, but the median is still 0. Because remember, the median is the value that comes after 2,202 people that's still in this first category. This first category still has more than half the people. So the median value is still one of these people that said 0. So that would be part B, right? Choice B. The mean will increase quite a bit, but the median will remain the same.